In this video, you will learn about the difference of two squares. So example 1, if you were to multiply x minus 2 times x plus 2. As we've learned, we can distribute x times x, and then x times 2, and then distribute the negative 2 to get negative 2 times x and negative 2 times 2. So if I do that, x times x is x squared, x times 2 is 2x, and then negative 2 times x is negative 2x, negative 2 times 2 is negative 4. So notice here what happens with the two middle terms, the negative 2x and the plus 2x. Those are like terms, and negative 2 plus 2 would give me 0, which means those would cancel. So my final answer is x squared minus 4. And remember, if you're trying to do this quickly in your head, we can do the first terms, so x squared, then do the outer, x times 2 to get 2x, that should be the plus 2x there, and then do the inner, negative 2 times x to get negative 2x. So I had these switched on accident, it should be plus, then minus. And then do the last two terms, negative 2 times 2 to get negative 4. Alright, so that is the shortcut way. But notice, okay, we have these two middle terms canceling out. That's going to happen every time when I see that the two things I'm multiplying together are different only by a positive or negative sign. So here, one is x minus 2, the other is x plus 2. So when it's 1 plus 1's minus, when that happens, the two middle terms will cancel. So the shortcut for a question like this, when one is plus, one is minus, is I simply take the first number squared and subtract it by the second number squared. So the first number squared minus the second number squared. So in this same example, x minus 2 times x plus 2, we see that one's plus, one's minus. If I do the first number squared, that would be x squared minus the second number squared, so minus 2 squared, which is that second term. So we have x squared minus 4, which is the same thing that I got over here. Alright, so we're going to try to get used to that shortcut. Here we have 3x minus 4 times 3x plus 4. So we see that it's different only by a plus and a minus sign. So using the shortcut, I can take the first number squared, so 3x, that whole thing, squared, minus that second number, the 4, squared. So just be careful with this first term that you are squaring the 3 as well as the x. So 3 squared is 9, then x squared is x squared. And then minus 4 squared would be 16. So my answer, using the shortcut, is 9x squared minus 16. And I can confirm that that is the correct answer. If I were to multiply through like normal, 3x times 3x, 3x times 4, negative 4 times 3x, and negative 4 times 4, we would get the same answer as over here. Okay, here's another example. We have m squared minus 3n times m squared plus 3n. So notice the only thing different again is the sign. One's minus, one is plus. So because of that, I can use this shortcut, where I take the first number, m squared, and I square it. And then I take the second number, 3n, and I square that as well. So m squared squared, like a power to a power, so I multiply 2 times 2 to get 4. So m to the 4th power. And then once again, for the second term, be careful with the 3. We square the 3 as well. So we square the 3 to get 3 squared, which is 9, and then square the n to get n squared. So my answer, using the shortcut, is m to the 4th minus 9n squared. And once again, this only works if the only thing is different is a plus and minus sign. Alright, and only with binomials, so it's got to have two terms. Okay, here is example 4. So once again, we have ab plus c squared times ab minus c squared, where the only thing different is the sign connecting the two. One is plus, one is minus. So therefore, I can use this shortcut. I take the first number and then square it. So ab, and I square that, minus the second number squared. So c squared squared. So here, don't forget with the first term that I square everything in the parentheses. So I square the a to get a squared. I square the b to get b squared. And then over here with the c, I have c squared squared. So power to a power, which means I multiply the exponents. 2 times 2 is 4. So my answer is a squared b squared minus c to the 4th power. And once again, I could confirm by going through the actual process of distributing. But because one sign is plus and one is negative, I can use this shortcut to get the same solution. Now, to finish this lesson, we're going to work in reverse. So instead of distributing the a plus b times a minus b, what we're doing is we're going backwards, and we call that factoring. So using the same exact shortcut, we're going to go backwards and factor. So we were told that a minus b times a plus b is the same thing as a squared minus b squared, which is where I square the first term and then subtract that from the square of the second term. So factoring is going backwards. So we have a squared minus b squared equals a minus b times a plus b. So for example, if you had x squared minus 9 and you were told to factor, meaning you're going backwards, so now we have two things in parentheses. What I do is I use this shortcut. We see here we have a difference of squares. We have something squared minus, and the 9 would be 3 squared. So x squared minus 3 squared. So using the shortcut in the backwards format, we take x and 3, put it here and then here, and just make one positive and one negative. So x plus 3 times x minus 3. Or the other way, x minus 3 times x plus 3. So all we're doing is we're going backwards. Before we had x minus 3 times x plus 3, we had to get to x squared minus 9. Now we're going the other way. So x squared minus 9 equals x minus 3 times x plus 3. And this right here is called the factored form of the original expression. This is factored. Okay, here's another example. X squared minus 100. Well, notice the x is being squared, and 100 is the same thing as 10 squared. So we have two things being squared and subtracted from each other. So this is called a difference of squares. We have two things being squared and they're being subtracted. So to factor, I take those numbers, the x and the 10, and I put them there and then here, and make one plus, make one minus. So it doesn't matter which one's plus, which one's minus, as long as they have different signs. So my solution, my factored form, would be x minus 10 times x plus 10. So that is the entire process. And I'm going to finish by showing you a few more examples. So the next example, we have 16x squared minus 25. So at first glance, this might not look like the same thing, but in reality, it is. So when we see this, we should notice that 16 is the same thing as 4 squared. So we have 4 squared and x squared. And we should notice that 25 is the same thing as 5 squared. So what we have is something being squared minus this other thing being squared. So it fits this format up here of a squared minus b squared. Something squared minus something else squared. Now the 4 squared x squared, I can write that a little more simply as 4x being squared. So because both things are being squared, I can put the squared outside of parentheses, signifying that it goes to both numbers. So I have 4x being squared minus 5 being squared. So now we have difference of squares. We have this is our a value, and then 5 is our b value. So when I factor, I take the 4x and put it here and here, and the 5 goes there. So then 1 becomes plus, 1 becomes minus, so we have 4x plus 5 times 4x minus 5. And again, it doesn't matter which one is plus and which one is minus, as long as they are different signs. Okay, here's another example. We have 4x squared minus 81y squared. So notice the 4 is the same thing as 2 squared. So 4x squared is the same thing as 2 squared x squared. And I can write that more simply as 2x and that entire thing being squared, because the squared would go to the 2 and the x the way this is written. And then the 81y squared, 81 is 9 squared. So we have 9 squared times y squared. So this can be written more simply as 9y, and that whole thing is being squared. All right, so here we can rewrite this as 2x squared minus 9y squared. So when I factor, the 2x is my a value and 9y is my b value. So the 2x would go there, and the 9y would go here and here. And then 1 is plus and 1 is minus. So that would be my factored form of the original expression. And if you're not sure, we can always double check by distributing back through, and we'd find that we get back out the exact same thing that we started with. So this here, the 2x minus 9y times 2x plus 9y, is my factored form. Here is another example. We are told to factor 25 minus 49x squared. So again, this would be a difference of squares because 25 can be written as 5 squared. And then 49x squared. 49 is the same thing as 7 squared. So we have 7 squared x squared, which can be written more simply as 7x in parentheses, and that is being squared. So the squared goes to both the 7 and the x. So I can rewrite this expression as 5 squared minus 7x squared. So the 5 is being squared and the 7x is being squared. So when I factor this, I take the 5 and put it here and here, and the 7x goes there and there. And then 1 is plus and 1 is minus. So my answer is 5 plus 7x times 5 minus 7x. Okay, 2 more examples. Next we have example 10. Factor 100x squared minus 81 times y to the 8th power. So this one looks a little different because of the y to the 8th power. Well, let's start with the first term, 100x squared. So 100x squared, you can think of 100 as 10 squared. So we have 10 squared x squared, which can be written more simply as 10x, and that whole thing is being squared. All right, so then we have 81y to the 8th power. 81 is 9 squared. Now y to the 8th power, this is the weird one, but I can think of this as y to the 4th squared, right? Because if you have a power to a power, you multiply the exponents. So 4 times 2 would give me the 8 back out. So the y to the 8th power is the same thing as y to the 4th power squared. So then I can write this more simply as 9 y to the 4th, and then all of that is squared. So the squared goes with the 9 and to the y to the 4th power. So this expression here I can simplify, or I guess rewrite, as 10x squared minus 9y to the 4th squared. So from here to factor, I take that and this. And then I can factor that out. So we're going to have 10x go at the beginning of both parentheses, and then 9y to the 4th at the end of both parentheses. So that's a 4 right there. And then 1's plus, 1's minus. So we have as our final answer 10x minus 9y to the 4th times 10x plus 9y to the 4th power. One more example. Here we have 81x to the 4th minus 16. So 81x to the 4th, I can think of that as the 81 is 9 squared. X to the 4th would be x squared squared. So more simply, I can write this as 9x squared. That whole thing is being squared, right? Because the 9 is being squared and the x squared is being squared, which is what we have up here. And then the 16 is the same thing as 4 squared. So we have 9x squared squared minus 4 squared. When I simplify, or when I factor, I should say, I have two parentheses. 9x squared would go here and here, and then the 4 would go there and there, and then 1's plus and 1's minus. So my factored form of the original expression would be 9x squared plus 4 times 9x squared minus 4.